This video is a bit of an introduction / reminder of solution calculations. So we're just looking at calculating concentration in moles per dm cubed and in grams per dm cubed. First, we'll just remind ourselves what concentration is. So you can have an option of very few particles dissolved in a solvent, which is normally water, and that gives you a dilute solution. And then you can have many more particles dissolved in the same volume, and that gives you a concentrated. So it's a measurement of the number of particles in a given space, a given volume of solution, usually dissolved in water. Notice that these two words often get confused with the words weak and strong, because especially in everyday life we tend to use things like, I like my orange squash really strong. There's no such thing as weak, there is a such thing as weak or strong, and in chemistry it has a very different definition, and you may have learnt it at GCSE, to do with how much an acid releases hydrogen ions in solution. So it's nothing to do with how many particles of acid there actually are. So weak and strong is a property of an acid. For example, sulfuric acid is a strong acid, ethanoic acid is weak, and that's an innate property of the chemical and shouldn't be confused with this, which is something we can change. So we can dilute something by adding water, we can change its concentration. We can't change if it's weak or strong. So what are the units of concentration? Well, we said that if we were going to describe it, it's the number of particles per the unit of volume. Now in chemistry we normally measure the number of particles in moles, and we normally measure the volume like we do for gases in decimeter cubed. So that can be written in moles per decimeter cubed, how many moles there are for every 1 decimeter cubed. Alternatively, like in physics, we could write that in moles per dm cubed. That's really helpful because it tells us how to do the calculation, because we've got to remember that per means divide. At A level and in some other books you will see it written like this. That still means moles per dm cubed. So get used to saying the words moles per dm cubed in your head. Don't say mole dm minus 3, because that doesn't mean anything mathematically and doesn't help you. Alternatively, occasionally we might measure, instead of number of particles, we might measure mass. There are some situations where it's more convenient to use mass instead of moles, and in that case we would just have grams per dm cubed, or we could have grams written like that, or of course GDM to the power minus 3. Grams per dm cubed is how we're going to say it every time. And we may have to convert between these two measurements, but that's easy and we'll look at that in this video. So how do we calculate concentration in moles per dm cubed, assuming we had the following bits of information? So say we had 12 grams of sodium hydroxide dissolved in 250 centimeter cubed of water, and we want our answer in moles per dm cubed. Well, I don't want to remember a formula triangle, I don't really need to remember an equation really, and that's because my units tell me everything. So my units of concentration are equal to moles divided by dm cubed. My calculation is right there. So all I need to do is work out moles and work out dm cubed. So first thing I've got is 12 grams. Grams is not moles, but I know how to convert them. I use the periodic table. So my moles of NaOH in 12 grams is going to be the mass over the RFM, or the MR. It's going to be 12. Check out the periodic table, add up sodium, oxygen, hydrogen, it works out to 40. Put that in the calculator and I end up with 0.3 moles. Next thing I need to do is work out my decimeter cubed. We did this when we were doing gas calculations. It's centimeters cubed divided by 1000 So that gives me 0.25 decimeter cubed. Some people put this divided by 1,000 into the equation. I like to separate them just in case it's in a different unit, like meters cubed or something like that, then you can use this technique every time. So my concentration is going to be the moles, 0.3, over the dm cubed, 0.25, and I'm going to get my answer as 1.2 moles per dm cubed. Or remember, it could be written moles dm minus 3. Okay, next example. What about if I needed grams per decimeter cubed? So it says solution of sulfuric acid has a concentration of 0.05 moles per dm cubed. What is its concentration in grams per decimeter cubed? So although I've got 0.05 moles, I'm going to write it like this to remind me how I did that calculation. How many grams per decimeter cubed? Well, if you're good at maths, you've already spotted that you can get rid of things that are on the same side, or both appear on both sides of the equation. So I can get rid of decimeter cubed. 0.05 moles per decimeter cubed tells me that in 1 decimeter cubed there's 0.05 moles. So I want grams per decimeter cubed, which means I just want to know how many grams there are in 1 decimeter cubed. Another way of looking at this is if you had a calculation in physics, and if you had something that was in 6 miles per hour, and you wanted to know how many kilometres per hour, all you would do is go, well, there's 1.6 kilometres in a mile. So I take my 6 and I times it by 1.6 to get kilometres per hour. At no point did you worry about hours in that calculation because they were the same, and so therefore they cancelled out. So the same thing is happening when you go between moles per dm cubed and grams per dm cubed. You're really just doing a moles into grams calculation. So if I want to know mass in grams, it's just going to be moles times the RFM. The moles is 0.05. Check my periodic table. Sulfuric acid is H2SO4. If I add all that up, I get the RFM of 98. And that gets me 4.9 grams. And I'm just going to remember that it asks for grams per dm cubed. So I'm going to write it, and I'll write it both ways so you get used to it. And that's all there is to it for the first bit of calculating concentration. In the next video, we'll look at titrations and how we're then using balanced equations like we were for the mass and the gas volume questions.